Hello friends, in this video we will look at the monkey and banana game code in Prolog. It's a very famous game and designing this particular game you will really enjoy and you will get an understanding of how the step-by-step problems are solved using Prolog language and it is also helpful in understanding the flow of control in a Prolog program and understanding how it is different from a regular C program. So this is the first example that I teach in my Prolog class after all the basics have been taught, and I hope you will enjoy the video. Please write in the comment section what you felt after watching this video. Watch it till the end to get a proper understanding of the concept. So let us begin. So in the monkey and the banana game, first of all, what is the problem? The problem is that there is a monkey in a room and there are bananas which are hanging from the middle of the roof. So the monkey wants to eat these bananas. Now monkey cannot directly reach the bananas from the ground. So he needs a stool for this. The stool is kept near the window which is there in the same room. So what the monkey has to do, he has to first walk towards the window, push the stool to the center of the room, climb that stool and then grab the bananas. So these are the 4 operations that are involved in this particular game, where the monkey will first walk, then push, then climb and finally grab the bananas. Now how do we tell the Prolog program how to differentiate between the different states and how to move from one state to another? Another thing is we want a program which is capable of calculating what steps to take depending on what is the entry condition that we give for the monkey. Say if I say that the monkey is already at the window, then the monkey doesn't need to walk, he just needs to push the stool, climb it and grab. If I say monkey is at the center, but the stool is at the window, so from the center the monkey has to go to the window, push the stool, bring it to the center, climb it, then grab the banana. So what steps should be taken? We want a Prolog program that can calculate the steps on its own. So as we can see here graphically, we have the door and the monkey is standing here. There is a chair or a stool near the window and there are bananas hanging from the center. Now what we want is that the monkey should walk towards the stool. Then the monkey will push the stool towards the center of the room. Then the monkey will climb the stool and then grab the bananas. So this is the sequence of steps that we want. So let us see how we can do this using a Prolog program. So the problem statement we have already covered. Now what we have to do is we have to model this problem inside the Prolog code. Now what are the 3 positions where the monkey and the objects can be at? The monkey and the object, the banana, the stool, they can be at the door, at the window and at the middle. These are the 3 locations which have been identified. At the door is the entrance of the room, at the middle is where the bananas are hanging and at the window is where the box or the stool is placed. Now initially the monkey is at the door, the box is at the window, bananas are at the middle and monkey is on the floor, and when he is near the box he can be on floor or on box. So these are the various places that the things can be at. Now we design a predicate state. Now what are the arguments for this predicate state? State is the state in which the monkey is at the moment. Now this composite variable, it consists of 4 components. The position of the monkey, whether the monkey is at the door, at the window or at the middle. Then monkey status, whether the monkey is on the box or on the stool or on the floor. Then we have the box, where the box is positioned, whether the box is at the door, is in the middle or near the window. And then we have the variable banana, whether monkey has the bananas or has not the bananas. So these are the various values these four variables are going to take, and this together, these four variables, they constitute this composite variable state. Now that we have this knowledge with us, we define the preconditions and the post conditions for the various operations that are allowed. Now we know that the monkey can walk, monkey can push, monkey can climb, and monkey can grab. Now in order to perform the walk operation, this status or the precondition in which the monkey should be is that a monkey should be at location L1, which can be any location depending on what is given to the program. Then the monkey should be on the floor in order to walk. He cannot be on box. On box he cannot walk. Then there is a position box where the stool is placed. Now this position, this L1 and this box, if they are same, then the monkey doesn't need to walk. That is, after performing this operation, the monkey will move from position L1 to L2, and the box is at this location. The monkey is on floor before and after the walk, and whatever is the status of the banana, the same status will remain, because after walking the monkey doesn't get the banana. So whatever was the previous state, the same will remain. Whatever is the previous state of the box, the same will remain. The only difference is that from location L1 we are moving to location L2. Then for push operation, push means that the monkey should be near the box so that he can push it from the box from the position L1 to L2. So both the monkey is at L1, the box is at L1, monkey is on the floor, and banana, whatever is the previous status, same will remain. And then after the push operation, both monkey and the box are at L2 position, and the monkey is on the floor, and the banana, whatever is the status, same will remain. Then we have climb operation. Now climb operation, both monkey and the stool should be at the same location, and monkey should be on floor. This is the precondition, and after performing this operation, post condition is now the monkey is on the box. The position of the monkey and the banana and the stool will remain the same. Similarly, we have the state grab or the grasp operation. In this, in order to grab the bananas, the monkey should be in the middle and on the box, because without that the grab operation cannot be performed. So monkey is at the middle, box is at the middle, monkey is on the box, and monkey doesn't have the bananas. This is the precondition, and the post condition is after performing this operation, the monkey is at the middle, the box is at the middle, monkey is still on the box, and now monkey has the bananas. So these are the four operations that we need to define. Now what we have to do is we have to define the do predicate, which will make sure that the monkey is performing these operations. And what is the order? The do predicate will convert one state into another state, the precondition state and the post condition state. So all the states that we have seen above. So the grasp operation, this is the precondition, this is the post condition, and this is the do predicate that we will call from our main function. So similarly, we have defined for climb, similarly for push and walk. We have defined the preconditions and the post conditions, and the do predicate is defined. Now what is there in do? It is simply receiving the state, and then it is telling which operation it is performing, and then what is the post condition. This it will return as an answer. So for all the four operations, we have designed the do predicate. After that, we have to design another predicate, can get. This predicate we will call from the Prolog prompt, and we will pass the initial state of the monkey, and after execution of the can get function, we will get as answer the plan that the game will calculate for us. So we will just specify the starting state. Plan is something that the code, this code is going to return to us. So here in state 1 we will pass the values. So whatever precondition has been passed by the user, that is given to the do predicate. Then the action is what we will receive from the do predicate, and the state 2 is the second or the post condition that we are receiving from the do predicate. Now again we will call the can get with this fresh state, state 2 or the post condition of the previous operation. And what we will do in the partial plan, we will attach the action and the partial plan together using the add predicate. So add predicate, what it will do? Nothing but whatever is the first argument, it will append that with the second argument and return that as answer. And why we have given this predicate over here? Because whatever are this underscore stands for anonymous values, and whatever is the status of these three variables, if the fourth variable will become has, that the monkey has the bananas already, then we don't need to calculate any plan, and we will come to the end of the program. There will be no further state defined after this, and we will return from the call to the do predicate. So therefore this is the ending condition that we have, and this is where the recursively we will calculate the next steps. So when we give this code to Prolog and then we execute this from the Now when we execute this code from the prompt after compiling, we will say can get state at door on floor at door has not. This is the initial state we are providing, and then plan Prolog will calculate. So it is saying that since monkey is at the door and stool is also at the door, then push the stool from at door to middle, then climb the stool and grab the bananas. Now if we say that the stool is at the middle and the monkey is at the middle, and the monkey is already on the box and the stool is also in the middle, then monkey, if doesn't have bananas, then he will simply perform the grab operation so that he gets the bananas. And after pressing the semicolon, it is giving false because there is no other solution possible for this. So we can see the chart for the execution. So as can be seen in this chart, this I have taken from the Clockspin book of Prolog, and it is a very famous book. And in this we can see first the grass predicate is defined, but depending on the precondition given by the user, first three operations are rejected and the walk is selected. Then second time or climb and grasp are rejected, and then push is selected. Then similarly grasp is rejected, climb is selected. So this is the flow of control of the Prolog program in order to execute the monkey and the banana problem. I hope this video is helpful to you in understanding the monkey and banana problem. And this problem is also related with the means and ends analysis, which is quite similar to this particular problem. So you can refer to that video also. And after watching this video, if you like my video, please comment in the comments section, like the video, share with your friends, and whatever is your feedback, please share with me. Thank you very much.